Hi, everyone, and welcome to Additive Manufacturing Simulation. I'm Alex Armstrong. I'm an expert services consultant with aPriori. This product demonstration consists of a 10 to 15 minute demo. But before we begin, a few housekeeping notes. If you have any questions after you do this demo, I'll be in a live meeting room from 2 p.m. to 5 p.m. Eastern Time. Feel free to join by clicking the Join Trade Show button in this virtual booth to connect and have your questions answered. If that time block doesn't work for you, or you prefer to meet one-on-one, you can also schedule a time with me via the meeting scheduler. On the event website near the chat panel, choose People, select my name, Alex Armstrong, and schedule a meeting with me. Alternatively, you can use the Leave Your Card button on the virtual booth page to have someone reach out to you. We have uploaded a PDF of today's presentation, plus additional resources, which you can access in the Files panel. So, without further ado, let's begin. Additive manufacturing in aPriori consists of 4 separate processes. The first of which is material jetting, which is what you might think of when you first hear 3D printing, where we're depositing strips of polymer material in rows and building up on top of the previous layers of material. In selective laser sintering, instead of depositing material by jetting it out, there's a reservoir of powder. It's the resin in powder form, and a laser will sinter or solidify the sections of that layer that should be formed into the solid material. And then we still, go back and forth in layers to build up the full product. In direct metal laser sintering, it's very similar to selective laser sintering. It's just that we have a metal powder instead of a polymer powder. And finally, there's stereolithography, where we have a liquid resin that's being cured as opposed to powder being sintered, but otherwise a very similar process to SLS. So I'm going to jump into a live session of aPriori, and we can take a look at a little demo. So I've got an example part loaded up here. You can take a look at the overall geometry so you have an idea of what we're making. And we're going to run through starting with a material jetting process and run through all 4 of the processes available to us. And in that time, I'll explain a little bit about how aPriori is working in the background. So we'll start over in the cost guide with the inputs, where you should generally start as always. And the main thing that you'll want to select after you've chosen your VPE is really just the material. The material in additive manufacturing is what drives the process selection, amongst other things. So if we come over to the material selection window, we can see that we've got a long list of materials of all different types. And really the main way you want to start off your cost is by opening up this section here so that you can see the process that each material is ready for, and potentially also the manufacturer of the equipment for that material. These 2 things can help you decide what's an appropriate material and also what process is going to be selected. You can see all of these materials are SLA, but if we scroll down, we can see some DMLS, and as well as 3D printing, which is what we're going to select today, right now. So I'll scroll down and select this VisiJet M3 crystal material. Click OK, and we'll give that a cost. So now you can see aPriori running through a couple options down at the bottom right here. It happens pretty quickly, but if you notice, it's really only evaluating 1 out of the 5 possible groutings, because this is a material jetting material. So aPriori only looks at the material jetting process. And you can see that that's what shows up in the Part Details tab over here. So you can see aPriori considers 2 different sections to the material jetting process. The first is the printing, where the machine is depositing the material in rows and columns and layers to build up the structure. And then there's also this break-off section here, which is accounting for the time it takes to break off the support structures that might be required, since if there's an overhang, we'll need some kind of support structure to deposit material on top of. So the final step there is just breaking that material off. We can see a similar site if we take a look at the manufacturing process section, and we can see some of the details of which pieces of support structure are being calculated by aPriori. So if you're interested in what aPriori thinks is necessary here, you can click on each of these support structures to take a look at what's involved, or even come down to this support structure GCD and the geometric cost drivers window. And now we're highlighting all of the support structures that aPriori is selected. So you can see there's the build direction that aPriori has selected to minimize the amount of support structure. And then we can also see in pink all of the support structures that aPriori has calculated for us. So it's taking into account the time it takes to create those, and also any material concerns that are appropriate. Something to note is also in these sort of circular overhangs, there are some additional support structures there. And one thing to note here that's true of most of the processes that we're going to go through is that if you find a support structure in any section, maybe this is a small support structure that you don't think is required, as the case may be, you can decide if you think one of those support structures is necessary. And if you don't think it is, we can right click on the support structure down here in the geometric cost drivers window and edit the operation. And now we can set that to a no cost feature. So this will tell aPriori to basically ignore that section of the support structure and potentially reduce the cost. So if we click OK, we'll see it updated, and we could recost the part to have in this case, it's a pretty small support structure. So we would end up with a slightly lower cost associated with it there. But otherwise, the rest of the results are pretty straightforward. If you're used to aPriori, you can review the labor time and costs buildup for the part details tab, sort of as normal. So that was our material jetting process. Swap over now to SLS. So I'll select one of our SLS materials. And as soon as I select, you can see in this process column, it's highlighted as SLS. So I might not have remembered that cast form PS is an SLS material, but aPriori is helping remind me there. So once I select that material, you can see that the process routing is aPriori computed. But when we hit cost, aPriori will know that's an SLS material and route us to the appropriate place. So you can see aPriori's finished costing, and we see now our piece part cost has come down. And we also see we now have a powder bed fusion and selective laser sintering processes selected. Something to note here is powder bed fusion is sort of aPriori's generic term for when you're fusing powder molecules or powder bits together into one solid object. So that would count for selective laser sintering and direct metal laser sintering, since those are sort of the same fundamental process, just slightly different materials. So they both fall under this powder bed fusion category. But within that, we can see there's a few more steps. We have laser sintering, which is, as we saw in material jetting, this is where most of the actual construction of the material is happening. But now we also have a cleaning step, and then powder recycling, which consists of sieving out the remaining powder that's left in the bed that wasn't sintered, and then loading that powder back into the hopper where the powder will come from for the next round. So aPriori is not only accounting for the cost of creating this part, but also resetting the machine to be ready for the next run. And we can see similar things down in the manufacturing process section. You can take a look at the laser sintering process and all of the different features within it, including build direction. So this is something that we saw earlier when we were reviewing the support structures in material jetting, but we can also come into the manufacturing process window. And as we come down through laser sintering as sintered, this build direction GCD might be helpful if you're not reviewing the support structures, but you're still interested in how aPriori calculated the build direction. So that's selective laser sintering. With that, we can hop over to direct metal laser sintering. So I'll select, again, we can come over to this process column, take a look at DMLS. So we have this aluminum material that's ready for us, and we'll select that and allow aPriori to select DMLS as our manufacturing process. All right, we can take a look now. You can see here our costs have increased slightly. So this metal material might be more expensive, or there could be other aspects driving that cost there. But we see some similar things to what we saw earlier. We have the metal sintering, the powder recycling, just the same as we saw earlier, as well as the break-off. And something I wanted to note here is that we also have some sub-processes that are outside of, if I minimize all of this additive manufacturing, there's some other processes that aPriori automatically includes for direct metal laser sintering, largely machining, because direct metal laser sintering is usually creating a part on top of a base plate of metal. There's some extra processes that are required to separate the final product from that base plate, in addition to the simple break-off processes that happen with SLS or material jetting. So something to note is there's the wire EDM process that gets added by default, and then a 3-axis mill process for finishing the build surface with a facing operation. So something to note is these happen sort of out of order with each other. Technically, the wire EDM would happen first. Just something to note that in this machining section, that's aPriori doesn't think that it's happening in that order. It's just the way it's represented in this window. You can also change the removal process from a wire EDM to just a machining process if you'd like, but that's a manual override. aPriori defaults to a wire EDM by default. Finally, there's a stress relief process and an ultrasonic cleaning process added by default, just to take care of any stress that's remaining in the part and to do a cleaning operation on the metal. So all of those are included by default, and they can be removed as needed, but in most cases that will usually apply. So with that, we'll move on to our last process, which is the stereolithography. Let's work with this SLA material that I've selected here. SLA standing for stereolithography, and give that a cost. So here you can see stereolithography falls under the vat polymerization category. In reality, right now it's the only process within vat polymerization, but in the future you could have, other processes that use a liquid resin as opposed to the powder for the other processes. So here we have something similar. Again, we have a resin curing process. This is where the part is actually being built. We have a break-off process, as we've seen before, but then there's a part curing step as well that adds in some extra cycle time and processing costs there. So with all of that said, those are the basics of cost of a part with additive manufacturing. One thing I wanted to note is that after you've come in, potentially you want to use aPriori to review the different types of additive manufacturing, find the most appropriate one for materials that you're evaluating. But this could apply to any other decision you're trying to make on a part. But in this example, we've costed through 4 different processes on the same part, and you can create a comparison over here to review one process against the other, or perhaps within one process you want to compare different materials. There's a number of different options that you could evaluate with one of these comparison reports. This just gives us a nice breakdown of, we start with material jetting on the left, stereolithography, SLS, and DMLS. And we can scroll down here after we get past some of this basic information that we inputted. We can also see a breakdown of the fully burdened cost. So here we can see that the material jetting process had a fully burdened cost of $144, $91 for the stereolithography. SLS had $67 and DMLS had $269. So that's interesting. If these were the 4 materials that were the best candidates for each process, we could easily determine that this SLS process would be the cheapest and probably the best choice here amongst the 4 options. So something to note is this definitely depends greatly on which material you're using, which could determine which machines are available and things like that. But based on what we're evaluating here, it certainly looks like this is the best choice for us. Now, one thing we could take into account is evaluating the annual volumes that we're creating here. So different processes could have different benefits and drawbacks in terms of how many parts you're making. So that might be the next thing to evaluate here is, should we do another comparison at different annual volumes? So I'll leave that for the user. That's the demo that I was hoping to run through today. So yeah, thanks everyone for your time. Appreciate it. And if you have any questions, you can feel free to join the live meeting within this booth by clicking the Join Trade Show button in the virtual booth. You can also download additional resources on this topic in the virtual booth. Schedule a time with me to meet one-on-one and view other demonstrations on the main product demo page. So thank you. Have a good day.